Okay, this is number 1, and we'll do this a little bit on the fly here, save a little bit of time. Let R be the region, the first quadrant bounded by the graph of y equals, let R be the region, bounded by the graph y equals 20 over 1 plus x squared, and below, by the horizontal line, y equals 2. So I kind of graphed it really fast here. You could just, put in your calculator. And you have to fix your window up because it goes up quite steep because when x is 0 is equal to 20. So that's what it looks like. And I'm just going to sketch this out and pencil it in, and hopefully we'll get something to work okay. And first of all, we want to find the area between here and here. And we can do this, we need to find the intersection, and they want to see the integral. So we want to find the area. So we can find where they intersect. And those were, we can set them equal to each other, and but it's easy enough to just do it like this. So I'll just go to intersect here. Intersect, head over here. First curve's down there. I guess you can see that. Enter. And the second curve's over here. Enter, enter. And I get 3. That's nice. So I get a nice 0.3. So we could have figured that out algebraically, but you got a calculator, so you might also do that. And we could just actually take the area equals the integral, and it's just going to be the top curve minus the bottom curve. So the top curve will be and we're going to go from -3 to 3. And since we have a calculator, we don't have to really worry about even using symmetry because it's easy enough with a calculator because we'll just math 9 it. And we're just going to have the top curve, which is 20, all over 1 plus x squared minus 2 dx. So there's your integral. That's how you find the area. Again, this would be my top curve. And this is my bottom curve, 2. Top curve minus bottom curve. And we could just do that on our calculator. So what we'll do is go, and without even putting that in, I can just use my var by vars. So I can say math 9. You can see that, math 9, okay. All right. And then I've got the first function is in y1, so I'll just go var y vars, enter, enter, minus 2. I can just put the 2 there if I want. Okay, comma, rather than even put the second vars in. And then x, comma, and I'm going to go from -3, little to +3. And we get 37. All right. 37.9, so we can round that off, so that's approximately 37.962. So that's pretty easy. That's no problem. Okay. It's the area between the two curves. Okay, letter B. Find the volume generated when R is rotated around the x-axis. Okay, so I draw a little sketch for this one. Okay. So there's my x-axis here. Lousy line. And this is y equals 2, I guess. And then our curve goes like this. And I won't have it go so steep just to make it a little bit easier. It goes something like this. And we're going to rotate this around the x-axis. So this is y equals 2. All right, so this is going to go down here to -2 because it's going to be on the other side. And my reflection would look something like this. So I rotate it around, we'll get something like this. Okay, so you can see we have kind of it's going to have to be a washer because there's a hole there. All right, and this is your top curve. Well, actually, let's look at the 2 radii now. So first of all, we have a washer method, okay? And we have to decide, is it going to be with respect to x or y? Well, the line of rotation is the x-axis, right? So that's just going to be dx. Okay. rotating around the x-axis, that's fine. Okay, and I need a big R, because it's the washer method, definitely the washer method. Okay, washer. So I'll need a big R, so that's going to be this whole thing. So here, if this is a typical washer, and this is a little inside, something like that. So there's kind of a typical washer. And I'm going to need a big R, so my big R is going to go from here all the way down to the x-axis. All right? So the bottom curve is 0, so my big curve is just this one. So I'll set up my integral over here. So the integral will be the integral from -3 to 3. And I got my pi is going to come out. This will be the volume. And this is going to be big R squared minus little r squared dx. So that's my general form for my washer method. So I need to figure out what my big R is. So big R will be just the top curve, which is this 20 over 1 plus x squared, minus the bottom curve, and the bottom curve is just 0. So that's just the top curve minus bottom curve. And the little r will be this one, which is just going to be 2 minus 0, which is just 2. Okay, so there we go. So we got our volume equals pi times the integral from -3 to 3, and that's going to be big R squared minus little r squared, so that's going to be 20 over 1 plus x squared squared minus little r squared. Okay, and little r squared is going to be what? Little r squared is going to be 2 squared. And there's your integral setup. So that's all you have to write down. Then we can calculate that out. And how would we calculate that out? Well, and this is just going to be this integral, and I'm just going to go. This will be my y1, so I can put y1 squared minus 2 squared is 4. All right. Let's just do that. That's pretty easy. So we go, turn this guy on, clear that, and we'll go math 9. Then we'll go var y vars. That's going to be my y1, and I got to square it. And then minus the little r, which was just 2 squared, which is 4, so I can just put the 4 in there, comma, x, comma, again, -3, comma to 3. And we get 5.95, and don't forget we have to multiply it by pi. Don't forget that, times pi. Don't forget this pi out here. Okay, so I'll take that and multiply that times pi, and we get 1871, so there's your answer. 1871.190. Okay, so nice washer method. Okay, nothing we haven't done, so you guys should be pretty confident with how to do that, okay? Okay, and the last one, letter C. Okay, it says that, okay, the region